Hi everyone, in this video we are going to discuss about Q versus K. Q is the reaction quotient and K is the equilibrium constant. Alright, so as usual, what we are going to do is we are going to write out the equation for our equilibrium constant, which is partial pressure of B squared over partial pressure of A. So each of these individual boxes refer to the partial pressures, whereas the sum of these boxes refer to the total pressure. Alright, so this is what we currently have, and since the system at the start, alright, is already at equilibrium, so I would say that I can calculate the value of K using this. So I have 2 square over 4, which is equal to 1. So we know that the value of K is 1, and at equilibrium the system will have a K value of 1. And so I would also like to fill in the information here. Okay, so this system is already at equilibrium, and if you look at the graph, it's probably already flat, right? A and B will already be flat at 4 and 2, and suddenly what I did was I added 2 atmospheres of B. So at this particular time T, okay, I added 2 atmospheres of B, so it shot up here to 4. Okay, so in fact, what you should do is take 2 plus 2 over here. But a very common mistake that many students make is they put plus 2 in the box of change, which is incorrect, because change means when the system is equilibrating, not whatever you add in. So when you add in 2 atmospheres of B, there is a new initial, there's an initial spike up. Alright, so this is our new initial over here. So I should have 4 of B and 4 of A at the start. Alright, and what happens right after that, at that instant, okay, we will have this thing called the reaction quotient. So at that instant, not at equilibrium, at the instant, what is the value of Q? And so it has the same equation of PB squared over PA. Alright, in this case it will be 4 squared over 4, and this will give us the value of 4. And you'll notice that since the value of Q is 4, it will want to tend towards K, which is 1. And so in order for Q to decrease from 4 to 1, the only way for us to do so is to decrease the numerator and increase the denominator, because this way it will allow 4 to decrease and decrease and decrease until it reaches 1. So a system will always want to go back to its equilibrium constant. So what happens here is during that change, alright, since B goes down, so we have 4 minus x over here. Okay, we can put 2x, up to you, and then A will go up, so it'll be 4 plus 0.5 x because of the ratio 2 is to 1 over here. And so, oh sorry, this is just plus 0.5 x, so the equilibrium will be 4 plus 0.5 x. This will be 4 minus x over here. So using this, alright, we will be able to solve for our value of x. So basically what we want to do is to substitute everything in, right? Because at equilibrium it will reach the value of k again, so we will have 4 minus x squared over 4 plus 0.5 x, and this will give us the value of 1. And what we can do after which is to solve it, and we will know what is the partial pressure of each individual gas at equilibrium, and to find out the total pressure, we can just add them together. Alright, so based on this question that we have, okay, we are going to introduce another new scenario, and this is one of the things that confuses a lot of students. So there are questions that talk about the addition of argon gas. Alright, where argon is unreactive, it is inert. So let's say I add 2 atmospheres of argon into this system. So what happens is you'll notice that nothing has changed. Alright, the initial partial pressure of A did not change. The initial partial pressure of B also did not change, because they did not react with argon at all. So what happens is that if you look at Q versus K, let's say I started off this with 2. Okay, I added argon instead of doing this step here. Right, my K will still be PB squared over PA, which is still equals to 2 squared over 4 equals to 1. So since Q is equal to K, there's no need for the system to equilibrate. So therefore, addition of argon will increase the total pressure, but it will not change any partial pressure, and hence Q is still the same as K, so there will not be any shift in equilibrium. So I hope this helps to clear things up.